103, section 6.3. Now, there are different type of concept that we want to use here. One is we have talked about discrete variable. Discrete variable is when the value of x is the whole number, is not a decimal number. And in that case, you always have a histogram or the bar graph. The value of x is whole number. You cannot take the decimal. Examples, number of patients who walk into doctor's office on particular day of the week, like on Monday. What's the probability of nobody walk into the office? 10%. What's the probability of 1? 25%, and so on. So we understand for probability distribution, first of all, sum of the px must always be 1. And the graph is a histogram. The probability is always between 1 and 0, and it has to be is equal to 1, and is always between 1 and 0 because it's positive. In a situation that you have a continuous variables, like temperature on Monday of summer of 2020. So temperature can take the decimal number. So what's the 0 temperature? 0.1, 0.2, 0.3. So you see in this case, you cannot really create a rectangle because there are so many of them. And even when you take like 1 and divide it into equal pieces, then you see there are so many small triangles. And when you take the top of all these rectangles and connect, you come up with a curve. So graph of continuous variable is a curve, is a bell-shaped curve. We also have a uniform distribution. Uniform distribution is a special case of discrete. Example, when you roll a die has 6 faces. A dice has 6 faces. When you roll a die, what's the probability of getting 1? 1 over 6. What's the probability of getting 2? 2, 1 over 6, 3, 1. See, they all have equal chance of occurring. So in that case, the probability remain the same, 1 over 6. So this is a uniform distribution. They call it density curve also. Density curve, uniform distributions. And then this type, when you deal with the continuous, there are 2 types of continuous. One is, they call it normal distribution, which normally give you a value for the mean and the standard deviation. And there is a special case of continuous variable that mean is 0 and the standard deviation is 1. They call it a standard distribution curve, which is the bell-shaped and symmetric. So for continuous, there are 2 types. One which has a mean of 0 and a standard deviation, they call it the standard. And the other one has a value, but 0 for mean, and the standard deviation is not 1. It could be any number. They call it normal distribution curve. So you see here, if number of rectangles in case of continuous, there are so many here, then eventually when you take the top of all this, when you take a top of all this rectangle and connect, you have a curve, a bell-shaped curve. It's like here. Look how many rectangles you have here. And the top would be a curve. This type of curve normally is a bell shape and it's symmetric. See, you could take the curve and split into 2 equal pieces. Area under the curve is always 1. Remember, we said sum of px is 1. So area under the curve is always 1. So if we ask you to tell what's the area of the half, half is 0.5. Half is 0.5. 0.5 and 0.5, so the area under the curve is always equal to 1. Here is an example of that when you have a density or uniform, when you have a uniform distribution which probability remain the same, how would you calculate? Like in these problems, the question is this: find the probability of at least 2. At least 2 means they want you to find the probability between 2 to 5. That means you need to find the area of this rectangle. Probability is always the area, in this case under this, or in case of the curve, is area under the curve, or in histogram is area of all the tables. Okay, so in this case, you already know from 2 to 5 is 3 units, and the height is the probability, the vertical axis is probability, which is 0.2. So if you take these two numbers and multiply that, give you the area of at least 2 minutes. Now these are, they want you to practice on some of the graph, like here, they're saying you have this graph, right? State the area under the graph between 10 and 25. Which one of these area is shaded between 25 and 10? See, is this one. Between 10 and 25, this is the area that we need to calculate. See, this is not like a bar graph. You don't have the rectangle that you could actually find the area. So you cannot really find the area just using the regular calculation of rectangles, because you have a curve. How would I calculate the area of the curve? I'll show you later on by using the table or the calculator to find the area of this curve. This is in case R is less than 32. Which one of the graph is R less than 32? The first one. When they say X is less than 32, means from 32 to the left, they want you to find this area. At least 25,000 means it's 25,000 and above. At least 25,000 means find the area of 25,000 and above, which is this one, 25,000 and above. In this example, the shaded area is given, and they are saying which one of this is correct. X is always between what, 4 and 7, right? And this is related to that. Now, in this example, the solution is here, and they want you to find the height of the density at X equal 1. First, they want you to calculate the height. And I have the solution here. The way I find the height is, if you remember in trigonometry, if there are two triangles like this, say one is AC, one is A, B1 and C1. Do you remember the similar triangle? Similar triangles is the formula that shows the proportion. So for instance, here we say AB1 from this small triangle, AB1. And what's the similar triangle in the big one? In the big triangle, what's the similar to AB1? AB over AB is equal, in a small triangle, B1C1. And what's the similar side in the big one? BC over BC. And then AC1 over, see, AC1 over AC. So we are using that property here to find the value of X in this case. Like here, they are saying that find the area when X is 0.5. See, from here to here is 1. 0.5 is almost half. They want you to find this area, which is a trapezoid. To find this area of the trapezoid, you need to find this height. To find this height, then we just say X over 2. See, these two are similar triangle. If I turn that, you could actually see, okay? Is X over 2, it's 0.5 over 1. So that's how they have it. X over 2.5 over 1 or X over 0.52. That gives you this value. Okay? And when you have that, then you could find the area. Or you could find this area and subtract from the whole things. That's another way to do it. What is the area when X is less than 0.5? Means if you put a 0.5 here, what is this area now? How do you calculate this area? Less than or equal to 0.45 means you have to find the area of this rectangle. Again, we find the Y value first. Okay, if this is Y, look, if this is Y, let's say 0.445 is here, right? And this is Y. Y over 2 is 0.45 over the whole things, over 1. So that gives you the Y value. And then multiply by this. Area of rectangle is base, multiplied by height, divided by 2. That's how we calculate the area for density curve. And this is very similar to that one. You know, we show you how to find the area for each of these. It's just you have to do some calculation here, understand, take a piece out, like here. These are easy, like which one of these is a shaded area? Of course, between 700 to 1100 is shaded. Find probability of X less than 1 is this one, right? X less than 1 is this. What's the probability of X greater than 3? X greater than 3 means this area. We will have to find this area. Which picture has probability of X between 2 and 1? Between 2 and 1, this is the area. Between 2 and 3 is this 2. And so on. This part is easy to find. This is again a density curve with a uniform P distribution, means Px is the same. See, I have a picture here. So the height is 0.1 or 1 over 10. What is the probability that at most is 6 minutes? At most 60 minutes is they want you to find this area. Probability is the area of this rectangle. They want you to find it from 0 to 6. We have the height is 1 over 10. We have the length is 6. So you do that to find your area, which is the probability. And then between 3 and 5, between 3 and 5, you have this area. This is your probability. Okay? So when you subtract it is what? 5 minus 3 is 2 multiplied by the height. All right, so that will end up section 6.3.